Python. So just to see, next one is just to see how the Python program execution will happen and how the Python architecture will be. Just we'll see that. I'm writing one simple Python program. Don't worry, this once installation is done, we will know how we will open this ideally and how this module which we can open and how we can execute this Python program and all. We'll see. So this is just introduction only, right? So we'll see that. Just I'm writing one simple program. I'm assigning A equal to 10 and B equal to 20. Print, I'm just printing. Print sum is equal to A plus B. This is a simple program. I'm writing it. 3 lines of code only. I'm writing it. Just I'm saving this. I'm saving into my desktop Python training. I'm giving file as add.py. So while saving this Python file, you need to give the extension like .py. Py means it's a Python file. It will understand. I mean, your compiler will understand this, and I'm saving it. Okay, just I'm running it. I'm running this module. So here, if you see, sum is which we are going to get. So what is going to happen internally? Once you try to execute this file, it means Python source code. This is called as Python source code. Okay. So how this source code will be converted into machine code, that we'll see in the step-by-step procedure. Okay. So first what we have done, we have written source code, right? Source code we have written. So what source code we have written? Just 3 lines of code we have written. So once the source code is written, what is going to happen is compiler will take that source code. Compiler will take that source code and it will be converted into bytecode instruction. Compiler, what it will do? It will be converted into bytecode instructions. So once this bytecode instructions got generated, so our interpreter are Python virtual machine. So Python virtual machine, what it will do? It will take the bytecode instructions which is generated by the compiler and it will be converted into machine code. So interpreter, what it will do? It will take the bytecode instructions and it will be converted into machine code. So here, one thing we should understand here, the compiler and interpreter, 2 parts we are going to use it here, right? So we can see the source code here and we can see the output. Once a machine code is generated, what interpreter will do? It will generate the output. It will generate the output as well. It will generate output as well. So here we can see the source code and we can see the output only, right? So in middle, what we are going to happening that we are not able to see. Why? Because this complete steps are doing by the interpreter. This complete selection which I have made it, this is done by the interpreter. But here we are saying the compiler, right? So the interpreter only the compilation will do by default inside, right? So we in the sense programmer or user, we no need to worry about the compilation. So interpreter Python virtual machine itself or interpreter itself will do the compilation. What source code we have written, it will take source code and it will generate the machine code. Once the machine code is generated, corresponding result will be updated to the processor, processor for execution. So that result which we can able to see the output. That is the interpreter work which we are going to do here. So whatever we are going to do here, this can we see? Yes, we can see this step by step. We can see. So compiler, what work it will do, source code it will take, and it will be converted into corresponding bytecode instructions. Okay. What interpreter will do? Interpreter will be converted into machine code. Once machine code is generated, what interpreter will do? Interpreter will again converted that into output. It will send the for processor for the execution. The result will be sent for processor for execution. Sorry, mission code will be sent to the processor for execution. Okay, let's see here. I'm taking one small. We have written the one module, right? So if you see, this is the module which we have written. So everything, whatever I'm writing here, we can call it as a module. That we'll discuss in further classes. Okay. So how the compiler will compile this file? That let's see what is going to happen. So I'm going to run here. What is going to happen once you start? Once you click on the run module, the execution is started directly. So the compilation, how it will happen? We no need to worry. Why? Because interpreter will taken care. But if I wanted to see how the compilation is happen, okay. So that let's see. We have one module called py compile. Py underscore compile. We have the one module. This is the module we have to compile the Python program. Okay, let's see how it generated the .pyc file. So if you see, this is the file which we have added, add.py. Okay, add.py is the file or module which, this is the Python module which we have written execution, right? So here what I'm doing here, just you see we have add.py and test.py. Only two files we have in this folder. What I'm going to do is I'm going to use py compile module, Python 3 -m py underscore compile. This is the module. Py compile. This is the module for getting the compilation file. And what is the module if we wanted to do it? Python add.py. This is the module which we have written for compilation, right? So just to see, this execution has happened. This execution is happened. Let's see whether the compilation file is got generated in the same folder. If you see, PyCache is one more folder created. PyCache folder, one more folder is created here. Let me go to that folder underscore PyCache. So I'm under PyCache folder, and if you see dir, this is the compilation file which is generated. Our add module. This is the compilation file which is generated for our add module. So how we can execute this compilation file? In the same way, Python add.py, add.cpython that compilation file which we are going to get. If you try to execute, the sum equal to 30 which we are going to get. The same result we are going to get here. So here, two-step process like other programming languages. First one is compilation can be done. Next one is execution will be done. Those are the two steps, right? But here, interpreter what is going to do for us? Compilation by default, it is going to happen internally. So programmer no need to worry about the compilation file. Compilation, right? So, but if you wanted to make .pyc files, we have the module called py underscore compile. So by using this, we can make the compilation file. So once you get the compilation file, okay, once you get the compilation file, by using Python command again, Python interpreter, you can execute that so that result will be getting it. Understood? Any questions? Okay. So if you wanted to see the Python bytecode instructions, we have one more module called this. We have the one more module called this module. By using this module, we can see the bytecode instructions, which is generated by the compiler. Okay. So let's see for the same module, whatever module we have it. Let me go back one step. So this is add.py, right? So what I'm trying to do here, Python M, this module. This module is for bytecode instructions. What I'm doing here, add.py. If you see, these are the bytecode instructions which we can see. These are the bytecode instructions by using this which we can see. So here, these are the lines of statements which we have written, right, in the source code. So these are the lines. How many lines we have written in the source code? 4 lines. So this numbers are representing to the source code line number. Okay. So here these are the statements for offset of the bytecode instructions, and this is the name of the bytecode instructions which we are going to see here. The load constant 10. A equal to 10 we have assigned it, right? So it loads the constant 10. See, this is what I'm telling. Keep telling you, dynamically typing, right? First it will load the constant. So load the constant in the sense whatever value dynamically we are passing it 10, right? So it will take that value. After that it will be assigning into a variable. Store name. Store name is the variable which we have assigned it A, right? So first it will load the constant, then it will store into the variable. It means here we are passing so that it will understand this is the excuse me. This is the integer. This is the integer, so that it will be the value will be stored into the variable A. Suppose if you pass the string, what is going to happen? It will take the string first, then it will store into the A. In the same way, I'm passed the second value as 20. So the store name, that is B. So here null in the sense we print in the print statement, first it will assign the null value, then load two statements A plus B we are passed, right? So in the print statement it will load that name and it will load the constant, and binary OP means it's adding the binary plus binary operator. So OP in the sense here operator in the sense plus symbol which we have used it, right? So the plus symbol is representing the binary operator. So then we are calling that, and it will the result will be return the constant whatever value which we are going to get. So these are the bytecode instructions. The compiler will be converted to understandable by the programmer. So what compiler will do by this module, what it will do, this module will be converted. This bytecode instructions usually we cannot understand, but this module what it will do, it will be converted into our understandable format. Okay, so these are the values which we are going to get it here by using this module. Understood? Any questions? So here the compiler will be converted into bytecode instructions. Interpreter what will do, it will be converted bytecode instructions into machine code. Then finally the output will be understood by the programmer. The interpreter only converted that into output. The output is understandable by the programmer or user, right? So here same result which we are going to get, sum is equal to 30. This is the one which we are going to get. Understood? Any questions here?
No.
Okay, sorry.
Yeah, no questions.
Okay, good. So this is how the Python compilation interpretation will be happening. Okay, if you write any Python program or Python instructions, this is how it will be executed. basically we will not use this IDE and all. I mean, whatever by default we are going to get, right? This IDLE and Python interpreter. This we will not use it in our promise, office promise. I mean, real world promise. What we'll do, we have the separate IDEs for writing the code. Okay, so those are we can use Eclipse or PyCharm or Eclipse or Visual Studios. We have an IDE is there. So those kind of IDEs which we can use it. So we no need to worry about the indentation and all. Why? Because by default the indentation will be included in the IDEs. So let's see, for example, I have the PyCharm which is installed in my computer. This is the IDE which we will use mostly for our development. So just to see, this is for .py. I'm writing one small function here, a comma b. I'm passing argument. See, if you enter, right, by default it has taken the indentation and all it has taken. So we no need to worry about the indentation and small things while writing the code. So the interpreter, sorry, the IDE will take care about these things. So just I'm calling it add of hi, comma, hello. Hi, comma, hello, I'm passing it. Will this work? Obviously, yes. Hi, hello. So here, dynamically typed, you understood, right? A will be taken by hi and B will be taken as hello. A plus B in the sense hi, hello, we are going to get. So here, if you pass 10, 20, here if you take 10, 20, 30 we are going to get. This is the result. 30 we are going to get. So that is called dynamically type. Basically, this IDE will use in the real time. So we no need to worry about the indentation and all. Okay. Next one is flavors of Python. Flavors of Python. So what is the flavor of Python? So basically, flavor is representation of Python compilers. Flavor is representation of Python compiler. So what compiler which we are using now? If you see the compiled file here, whatever compiled file which is generated by our program, which compiled file is generated? Let's see. Let me open that. If you see the PyCache, right? In the PyCache, with what Python file it is generated? C Python, right? So here, the C Python is the standard library which we are using and we are executing in our system. So here, whatever which we are downloading from www.python.org, once you download the software from here, Python 3.12.2, by default, C Python which we are going to get. Why? Because what is C Python here in the sense, whatever interpreter or whatever compiler which we are talking about, those two which are implemented completely by using C language functions. Understanding what I'm trying to say? Python compiler or Python interpreter which we are executing in our system, that is completely written in the form of C functions. That is completely written in or implemented in C functions, C libraries or C functions, C language functions. Okay, that is the reason this compilation file which is generated here, it is C Python library file. The compilation is C Python library file. Okay, so here even compiler also implemented in the C language function only. Even interpreter also implemented in the C language functions only. So that is the reason this is standard library which we are using it. That is C Python compiler which we are going to use. Next, C Python, this is the standard library which we are using it. Standard library which we are using now in our systems. Next, Jython. Jython is the one of the flavor of Java plus Python. Java plus Python. So in C Python, what is going to happen in the sense, whatever source code we are writing it, the compiler which is implemented in the C functions, so that will take the source code and it will be converted into bytecode instructions, right? So again, that bytecode instructions, again, these bytecode instructions will be taken by the interpreter or Python virtual machine, which is also implemented in the C functions. Okay, so that will be converted into machine code, right? So that is the reason C Python which we are saying it. Here Java plus Python, we can call it as a Jython. So here what is going to happen here is, we are writing the source code in the Python. Okay, so the compiler, what it will do, the compiler will be converted into bytecode instructions, right? So we have the Java virtual machine. Okay, so Java virtual machine will take whatever bytecode instructions which is generated by the compiler, Java virtual machine will take and it will converted into .class files. It means Java understandable format. Understanding? So what I'm trying to say here is Python code we are writing it. So the Python code, if you wanted to execute, we need Python virtual machine basically, right? But in Jython, what we are going to get it. So if you wanted to implement Python in Java platform, how we can do that? How if you wanted to run Python code into the Java platform, we have Jython, one flavor we have. So what this Jython will do, whatever Python instructions which we are writing it, that will Jython compiler will convert that into Java understandable format. Java understandable format, and the result will be converted into machine code. That is common for how the JVM will work, Java virtual machine will work. The same way, but the main thing here is the conversion from Python to Java. So Jython compiler, what it will do, it will convert from Python program to Java virtual machine understandable format. That is the main point here, which I'm trying to say here. Jython is the one more compiler based program. Python programs, we can run it into the Java platform also. If you wanted to merge Java plus Python, in the sense, we will use the Jython compiler. In the same way, we have Iron Python. We have Iron Python. So if you wanted to integrate Python with .NET, we have the Iron Python compiler. We have it. By using this, you can integrate Python with .NET. Python with .NET. So like that, we have many flavors. We have one more flavor, PyPy. So if you see the standard Python, right? In standard Python, sorry, in C Python, we are using Python libraries in C Python only, right? So PyPy, in the sense, whatever compiler which has written in C Python by using C language, right? Even interpreter also written in the C language. But in PyPy, This is completely written in the Python language. So what it has written completely in the sense compiler and interpreter completely written in Python language. Okay, that is the reason PyPy. PyPy in the sense Python over Python. This Python compiler and interpreter both written in the Python language only. So if you compare C Python with PyPy, okay, PyPy is compared to C, it is more faster for execution, more faster than C Python. So why it is more faster in the sense we have just in time compiler in Python virtual machine, which is implemented in the Python. Okay, so here two steps, right? First step is compiler, what it will do, source code into bytecode instruction. Interpreter, what it will do, it will take the bytecode instructions and it will be converted into machine code, right? So here, in the once bytecode instructions got generated, Python virtual machine will have the just-in-time compiler in the interpreter, so that it will be execution time is more faster than C Python. Whatever C Python which we are using it now, so Python is more faster than C Python which we are using it now. Why? Because just-in-time compiler we have in the Python virtual machine, developed by Python or implemented in Python. Okay, that is the reason more faster, which we can use it PyPy instead of C Python. Okay, so like this we have Ruby Python. We have Ruby also, one language we have. If you wanted to implement our Python into Ruby, I mean, we need support to Ruby in the sense we can use the Ruby Python compiler and Anaconda Python. Basically, Python is for little bit small applications. This Anaconda Python compiler will use for a large set of applications, large set of data scaling. If you wanted to do it, we can use it by using Anaconda Python. Anaconda Python. So these are the most of the flavors which we have it in Python. Any questions?
No, sir.
Okay, these are the flavors. Next, in the next session, we'll discuss about what is the identifier and what is the keywords which we have in Python. How we can write the names like function names or variable names. How we can make it. So those things we are going to discuss in the next session. Okay. Yeah. Thank you.